Sketch a graph of y equals x squared minus x minus 4 by finding the x and y-intercepts and plotting two additional points. Again, we'll start with the y-intercept because that's the easiest one to find. We know that the y-intercept just comes from the constant term. In this case, that's negative 4. So we have a y-intercept of negative 4, and we can plot that on the xy plane right now. Next, we'll find the x-intercepts. We know that we can find them by letting y be 0. So that gives us 0 equals x squared minus x minus 4. And we need to solve this quadratic equation to figure out the x-intercepts. Now this one is not factorable because there are not two numbers that have a product of negative 4 and a sum of negative 1. That means that we're going to want to use the quadratic formula. So we've got x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Let's plug in these values and figure out the intercepts. B is negative 1, so then the opposite of b is going to be a positive 1, plus or minus the square root of b squared, negative 1 squared is positive 1, minus 4 times a, which is 1, times c, which is negative 4, all over 2 times a, which is going to be 2 times 1. Now let's look underneath that radical. We've got 1, and then this subtraction is going to turn into an addition because these two negatives will cancel out. So it's going to be 1 plus, and then 4 times 1 times 4 is 16. And then in the denominator, 2 times 1 is 2. Finally, underneath that radical, 1 plus 16 is 17. So we end up with 1 plus or minus the square root of 17 over 2 for our x-intercepts. Now, to figure out where we need to plot these on the x-axis, we need to come up with decimal approximations for these two intercepts so that we can figure out where they go. So one of them is going to be 1 plus the square root of 17 all over 2. The other is going to be 1 minus the square root of 17 over 2. And I'm just going to use a calculator to get approximations for each of these. All right, 1 plus the square root of 17 all over 2 is approximately 2.56. And then 1 minus the square root of 17 over 2 is approximately negative 1.56. So we need to plot these numbers on the x-axis. 2.56 is just over 2.5. So it's going to be just over halfway between 2 and 3. Honestly, because we are not robots and we can't draw perfect graphs, putting it halfway between 2 and 3 is perfectly acceptable. Really, if we're getting to the nearest tenth, I think we're doing a pretty good job. Now, we also have negative 1.56. It's going to be about halfway between negative 1 and negative 2, maybe the tiniest bit closer to negative 2. So we'll put that there. Now we have 3 points. We can see that this is going to be an upward opening parabola from the graph and also from the fact that the leading coefficient is positive. But we do want a couple more points to get an idea of what this is going to look like. I think x equals 1 will be good because that'll tell us if this is lower or higher than that point. And then also probably x equals 3 because we can see how high up it's going to be. So for our x values, we'll pick 1 and 3. Let's plug those in. X equals 1 gives us 1 squared minus 1 minus 4. 1 squared is 1. And the 1's cancel. 1 minus 1 is 0. That leaves us with negative 4 for y. And we can plot that now. 1 comma negative 4 is right there. And then we try 3. This gives us 3 squared minus 3 minus 4. 3 squared is 9, so we've got 9 minus 3 minus 4. 9 minus 3 is 6, minus 4 is 2, so we end up with the point 3 comma 2, which is right here. And we can draw in our parabola just like this. And that gives us y equals x squared minus x minus 4. All right.